Okay, so today we're going to be talking about graphing rational functions. And so the types of questions we're going to graph are going to be with x's and fractions. And so, obviously we can put them in a graphing calculator and see what they look like. But not only that, we also want to talk about the asymptotes and talk about their end behavior and talk about x-intercepts and be able to describe them rather than just see a graph and say, hey, it's got, multiple branches and this is what it looks like. So let's talk about algebraically how we can deal with these values. Okay, so the first thing is, if we're looking at a fraction, we want to find out, if you made a table of values, what would be part of the domain, etc. Okay, the range is sometimes hard to talk about, but I would say the domain would be anything except for the values that make the denominator 0. And so one way to get to that would be to factor the top and the bottom. So on this first question, okay, so we're going to factor the top and the bottom. And the top does not factor, and so the denominator becomes x minus 4 and x minus 3. And so with any function, you cannot plug in values who cause the denominator to be 0. So the values that make the denominator 0 are going to be gaps. Okay, and so in this case, the values that make the denominator 0 are going to be actually not just a gap, but a vertical asymptote, where the graph will go towards it, but will never actually touch it. So the values that make the denominator 0 are going to be vertical asymptotes. So the equation of the vertical asymptotes will be x is equal to 4 and x is equal to 3. And so on the next question, you've got to factor it by grouping, and you take out an x squared, you're left with x plus 1, and then you take out a 4, and you're left with x plus 1, and then you get x minus 1 on the numerator, and the denominator is x squared plus 4, and then also x plus 1. So the values that make the denominator 0 would be x equals negative 1, so that would be a vertical asymptote. Now the other question though is, if you set the other one equal to 0, you get x squared is equal to negative 4. Well, that's going to be plus or minus 2i. There aren't 3 asymptotes. Okay, there's only one vertical asymptote in this case. So vertical asymptotes are the values that make the denominator 0. Obviously, you're not going to try to plug in an imaginary number for x when you're trying to graph a function. You're going to just plug in real numbers. So the real numbers that are excluded values from this would be just negative 1. So the domain would be all real numbers except for negative 1 in this case. So that's the vertical asymptote. Okay, and so we're going to start building kind of a graphic to say the vertical asymptotes on the bottom. And then the next thing we're going to talk about would be another fact, kind of like what goes with this would be to find the x-intercepts and the y-intercepts. So the zeros would be on the numerator. Okay, so if you look at the numerator, if there's factors on the numerator, the zeros will be the factors of the numerator that have letters in it. So on that second question, it would cross the x-axis at 1, 0. Okay, so the zeros would be the numerator's factors. So if we look at this, the directions say, okay, what we should do is we should factor, okay, because that's going to help us find the zeros on the numerator and the vertical asymptotes in the denominator. Because when the numerator is 0, that causes the answer to be 0. So use the numerator to find all the zeros. Okay, so that goes up here. Find the asymptotes. There's 3 kinds of asymptotes that a graph could have. The vertical asymptote is on the bottom. Okay, so anything that makes the denominator 0 is going to cause a gap or a vertical asymptote. And then the next kind of asymptote we're going to look for would be a horizontal asymptote. Now, there's a couple ways to think about this. A horizontal asymptote is kind of like a lid, okay, to say how high does your graph get. And so looking for a horizontal asymptote is kind of like looking at end behavior, okay? And so we're looking to say, does your graph approach a highest bound, or does it just go up to infinity? Does it go to negative infinity? What does your graph do if you plug in big numbers for x on either side of the factor? And so to look for that horizontal asymptote the graph will get to, or move to as you plug in big numbers for x or very negative numbers for x is best obtained when you look at the highest degree term. Just like with end behavior, we did our arms to say, look at the highest degree term to see if it's even or odd and see if it's positive or negative, and we could tell what the end behavior did. Well, because this is a fraction, it's a little bit more complex, but not that much more. Okay, so let's start with the middle one. On the middle one, the highest degree terms are both x squared. So technically, those are the most influential terms. And it's kind of like being a millionaire. You're like, okay, if you add $2 to your million, it doesn't change a whole lot. Okay, so look at the highest degree terms. They do need to match, okay, so that you can kind of see what's going on. So frankly, if you're looking for the end behavior, you focus on the highest degree terms and they have to match. And then you look at that ratio. So 3x squared over 6x squared, 3 times a big number over 6 times that same number reduces to 1/2. So the horizontal asymptote is y equals 1/2. So you'll notice if you graph this function, the graph will suck towards y equals 1/2. It may come at it from the top or the bottom or both, okay? Well, actually couldn't do both, but top or the bottom because it's a function, and that will be kind of the end behavior on at least part of your graph, okay? And so there's more to it, obviously, but we're going to just say it's the end behavior looking at the highest degree terms. Now, if you look at number 5, if you notice there, the highest degree term is x to the second. Well, you have to have a matching term, so you place a placeholder, like a pairing up, okay? Give it a couple, okay? Make it a couple. So it's 1x squared over, say, 0x squared. And you make like a capital H, okay, of the highest degree terms. Okay, so what we want to do is write a ratio of those highest degree terms, okay? And so the highest degree terms are going to be 1x squared over 0x squared. Because frankly, if you look at end behavior, we want to focus on the highest degree terms. So frankly, for the end behavior, all these other terms don't matter. So it's going to be 1x squared over 0x squared. The truth is 1 divided by 0 is undefined. Okay, and so therefore, there is no horizontal asymptote. Okay, no horizontal asymptote. Now let's go back and talk about what's actually going on. Okay, if you reduce out all these terms, you end up getting j of x really will resemble x squared. X squared, as x goes to infinity, your function goes to infinity as well. And so there's going to be no bound to the right side of this function. It's going to go to infinity. And so what we're looking for is the end behavior. There is no lid on this this graph right here because 1 divided by 0 of the highest degree exponents doesn't exist. And so if you plug in a big number for x, there is no highest bound. It just goes to infinity. So there's a logic, but also like 1 divided by 0 doesn't exist. So there is no horizontal lid or asymptote that it goes to for the end behavior. On the very first question, if you notice, we're looking for the highest degree term, which is x squared. And so you do 0x squared. Okay, and so if you write a ratio of those highest degree terms, it's 0 over 1. You can write a coefficient here. And 0 over 1 is 0. So y equals 0 is going to be the horizontal asymptote. So your graph is going to go towards the x-axis. And if you think about it, think about this. Okay, if you've got h of x is equal to x minus 5 over x squared and stuff like this, the only thing that matters is going to be the x squared. So it's going to be 1 over x squared. If you plug in a very, 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 very large number for x, 1 divided by 1,000,000 is going to be close to 0. It's a very small number. And so basically, we're looking to say, what is the end behavior of this graph? Okay, does it go to a specific output value? And if so, it's going to have a horizontal asymptote. If it does not, then you're going to say, no, it goes to infinity or negative infinity or something like that. So we're looking at the ratio of the highest degree terms. If it's 0 over a number, you write 0. If it's a number over a number for the highest degree terms, you write that number. That's the value it goes towards. And if it's 1 divided by 0 or a number divided by 0, there isn't one because it probably goes to infinity or negative infinity. So horizontal asymptote has to do with the end behavior of your polynomial. And you start with the highest degree term and compare that ratio to see what is the end behavior of your graph. Now, there are times you know that as like graphs that are fractions, we could actually divide them. Okay, and so if you actually divide them and see what you get, it may have some asymptotes that are like a parabola if you divide them, or they may have an asymptote that's going to be a line if you're going to divide them. And so sometimes they're going to ask you to say, does your graph have another asymptote that is a different shape? And so if what we'll mostly look for is the division of your polynomial going to be a line? And so is there a slanted asymptote, y equals mx plus b, that resembles your graph as well? Is there an asymptote that's kind of on the slant? So a vertical asymptote is the bottom. A horizontal asymptote is going to be the end behavior, where you write the ratio of the highest degree terms. And then the slanted asymptote is going to be, if you divide it, what shape do you get? What shape does your graph actually resemble? Now, we will not be looking for anything other than a line. So what we'll do is we'll look to see if the numerator is 1 degree higher than the denominator. That's why when you divide it, you're going to get a line. Okay, so we're going to check to see if the quotient of actually dividing these gives you a line. And so since it's kind of like resembles it, okay, we're going to divide it and see, we ignore the remainders because it's kind of ish. Our graph will go towards that line. Okay, so if we divide these two values, and notice the degree of the numerator is 1 higher than the denominator, so then when we divide it, we're going to get a line. So if you divide this into here, you get an x, and you get x squared plus 3x distributed -1. You get negative 7x minus 5, so you put -7. And then you get negative 7x minus 21 distributed negative. Now, because we are going to be saying what does it resemble, we don't care what the remainder is, okay? So if there is a remainder, your graph actually isn't a line, when you graph it. If your graph has a remainder, it will go towards that line, okay? So since there's a remainder, your graph goes towards that line as an asymptote. So the equation of the asymptote that's slanted or oblique is going to be y equals x minus 7. So we ignore the remainder. No, our graph isn't going to be a slanty line. It's going to go towards a slanty line. Okay. Now the next one, if you divide that, it's an improper, or it's not going to make a line because the degree of the numerator is not 1 bigger than the denominator. So we're not going to actually divide that. So if you divide that, it's not going to turn out very cutely. So we're just going to leave it like this and graph it as it stands and look for other kinds of asymptotes. So this does not have a slanted asymptote because the degree of the numerator is not just 1 higher than the denominator. Okay. So moving forward, how is this going to, there's holes. Okay. So going back to our original thing, when we factor it, the numerator is zeros, the denominator would be vertical asymptotes. And if there is a factor that's on top and bottom, a common factor, we call that a hole. Okay. It's not a zero or a vertical asymptote, it's a hole itself. Okay. So there's like a discontinuity where actually you will make like a pothole on your graph and just make like an open circle, kind of like when you're graphing inequalities, it doesn't actually equal that value. So if you see a common factor on top and bottom, you're going to put a hole at that point. And let me teach you what I mean by that. Okay, so let's get over here. So to do holes, again, you got to factor it. All right, here we go. So if you factor this first one, you get x plus 2 and x plus 1 over x plus 2 and x minus 2. Okay, so and I would say you start by looking for the holes. Okay, so when you see this right here, you're like, okay, there's a hole at the x plus 2. Okay, so that's a hole. I'm going to write hole. And then the numerator is going to be the 0. Okay, now x plus 2, that's just a hole, it's not a 0. And then the denominator is going to be the vertical asymptote. Okay, so this is a vertical asymptote here. Okay, so what we would say is there's a hole at, I got to get rid of my highlighter, it's kind of ridiculous. The hole occurs when x is at -2. Okay, so it's still not part of the domain, it's a problem, it's a discontinuity as they talk about here. The 0 is going to be -1, 0, and the vertical asymptote is going to be x is equal to 2. Okay, so those are going to be the 0 and the vertical asymptote. The hole is going to be at -2. And how you find the output of the hole is you actually reduce this and you say, okay, I could write this function in the original form. I can write it as a fraction that with all the 4 factors there, or I can say it's also just equal to x plus 1 over x minus 2. And so if you plug in -2 to the most reduced function, so plug in x is -2 into that most reduced function, you do -2 plus 1 over negative 2 minus 2, you get negative 1 over negative 4, so it'd be 1/4. Okay, so if you plug that in there, you're going to get, let me make sure I did that correctly. So negative 2 plus 1 is going to be negative 1 over negative 4 is going to be 1/4. Okay, so yeah, that's going to be where the hole is. So when you get to that point, you make an open circle there. Okay, so you put an x-intercept at negative 1, 0, you draw a vertical asymptote at x equals 2, and you make a hole at negative 2, 1/4. Okay, so if there's a common factor, then you would do that. Okay, this last one, actually, if you factor the denominator, you get x minus 5, and you get x minus 5, and then x plus 4. Okay, so there's a common factor at, let's go ahead and do what we're doing. Okay, here we go. So there is no 0, okay, none. Okay, there's no x-intercepts because sometimes your graph doesn't touch the x-axis, okay? There's a vertical asymptote at x equals negative 4, okay? And then there's a hole, okay? Hole, okay? And that's super messy, but there's a hole at 5, okay? And to find the answer, you reduce it and you say, okay, that's going to be 1 over x plus 4. So we reduce it, we plug in 5 for x, so 1 over 5 plus 4, so that'd be 1/9. So that's where the hole is. So there's no vertical asymptote, or there's no x-intercept. The vertical asymptote is going to be x equals negative 4. So we're starting to build, like you can graph those asymptotes as dotted dashed lines. You can make open circles for holes. You can, if you can divide the fractions and they make a line, okay, with a remainder, then you're going to get a slanty asymptote, okay? Look at this first one. What would be the horizontal asymptote here? The horizontal asymptote would be y is equal to 1, okay, because 1x squared over 1x squared. So this is going to be, the horizontal asymptote is going to be y equals 1. This one right here, the highest degree term is x squared. This would be y equals 0, would be the horizontal asymptote. So we're looking to find each of those pieces, and so we can do that with specific questions now, okay? And then we get our graphing calculator out and we do second table. We can get some actual points, okay? So all right, let's go ahead and do this. It says, let's state the zeros, the asymptotes, and the holes that exist. So I think the first thing would be, let's factor it. Okay, so if we factor this little stinker, we get x squared on the numerator, and then on the denominator, we get x plus 4 and x minus 3. Okay, and so let's look at the x-intercepts and the y-intercepts. Okay, so if you look at your chart, the zeros are on the top. Those are x-intercepts. We got the vertical asymptotes on the denominator, and we got holes here. Okay. And so, okay, there are no holes because there's no common factors on top and bottom. The vertical asymptotes, we'll get to those next. So let's start with x-intercepts. The zeros or the x-intercepts would be when the numerator is 0. So that would be 0, 0. So x-intercept is 0, 0. You can also find the y-intercept by plugging in x is 0 to all the x's to find what y would be, and it's still 0, 0. So the x and the y-intercept are both 0, 0. So you can plug in, set the numerator equal to 0 to find the x-intercepts, plug in x is 0 to find the y-intercept to find what y is. In this case, they're the same number. So those are the intercepts. And then let's do the asymptotes. The vertical asymptote would be the ones on the bottom. So that would be vertical asymptotes would be x equals negative 4 and x is equal to 3. So we can go to negative 4, 1, 2, 3, 4, and then x equals 3. 1, 2, 3. Okay. And then the horizontal asymptotes, again, we look at the highest degree terms to figure out the end behavior and go to the original unfactored form. So x squared is the highest degree terms. And I just wrote in marker. Let's do a highlighter. So the highest degree terms would be 1x squared over 1x squared. So the horizontal asymptote would be y equals 1. And then we also have, we'll check to see, is there a slanted? No, the degree of the numerator is not one higher than the bottom. So making a division problem on this doesn't make sense. And then there's no holes, okay, because there's no common factors on top and bottom. So what we will do is we'll plot 0, 0, which is one of the points we came up with. We've got our asymptotes on here. We would do second table. And one thing I would recommend is when you put this in your calculator, instead of doing the fraction key, take the numerator in a parentheses and use division, and then put the denominator in a parentheses, a single parentheses. And if you do that, your answer will be as decimals and as compared to fractions. And so, because fractions sometimes are hard for kids to understand what to do. And so if you plot the actual points to your second table, get some of those points, and you will get your graph to look like this. And then if you get a couple points over here, you will get, let me see if I can find some of these things. 3 is going to, or actually 4 is going to be 2. You can get some points over here. And then if you go to, like, say, -4 and 5 and 6, you get -6 is 2. And so that's going to be over here as well. So you can plot a couple of those points to get the actual graphs. Could you make a table? Yes. Okay. The domain would be anything except for -4 and +3. And at those points, you'd see vertical asymptote. So you'd see an error when x is -4 and when x is +3. Okay. So that is our first graph. The second graph we're going to talk about would be as shown. And so the first step is to factor it. And so if we factor this, we get x plus 3 and x minus 3. And the denominator is going to be x minus 3. Do you see that common factor is going to be a whole? So there's going to be a whole at 3. Okay, and so we're going to kind of either cross that out or just say, hey, what would be the equation when we would graph this? Okay, this actually is going to be y is equal to x plus 3. Now, the weird thing is this, okay, because we have a whole, okay, we plug in 3 into this reduced function, and we get, there's going to be a whole at 3, 6. So we go to 3 and up 6, 1, 2, 3, 4, 5, 6. And we make an open circle here. And we can answer the other questions. Okay, so let's do this. The x-intercept is going to be the numerator's value, so it'd be -3, 0. Again, it can't be a whole and an x-intercept. So -3, 0 is going to be an x-intercept. The denominator is going to be a vertical asymptote. There aren't any more denominator values. It can't have 2 jobs, so there is no vertical asymptote. The y-intercept, if you plug in x is 0 to your original function or the reduced function, you're going to get 0 is 3. So the y-intercept is at 3. And then no vertical asymptote. The horizontal asymptote, there isn't one of those either, because if you do the highest degree terms here, you look at x squared, okay, 1x squared over 0x squared. 1 divided by 0 is nothing. Okay, so there is no vertical asymptote. So if you look at this and you reduce out all the stuff, you're going to get x squared over nothing, and so it's going to go to infinity. Okay, so the right bound is really going to be going to infinity. You don't have to know that, but just 1 divided by 0, there is no lid or horizontal asymptote. And then if you graph this in your calculator, you'll notice it's a line. Now let's talk about this. There should be a slanted asymptote because the degree of the numerator is 1 higher than the denominator. So if we divide x minus 3 into x squared plus 0x plus 9, actually minus 9, I lied, minus 9. Let me erase that. If we divide that, we will notice that you get x squared minus 3x, distribute a negative, you get 3x minus 9, you put a 3 here, and you get 3x minus 9, distribute a negative, and you get no remainder. So the truth is, yes, there is a slanted asymptote, okay, of y is equal to x plus 3. But guess what? Because there's no remainder, the graph actually is y equals x plus 3. So when there's a remainder, it's kind of like a suggestion. So your graph is actually equaling the graph y equals x plus 3, but it does have a hole at the value of 3, 6. So it's kind of a weird situation going on. So if you get an asymptote and you divide your fraction, it actually just equals a specific polynomial, your graph will be equal to that polynomial, with a couple of extra features. So yes, we've got x-intercept. There is no vertical asymptote. There is no horizontal asymptote. And that's all we got. Okay, so let's look at the next question. The next question, if we factor it, you take out a 4 and you're left with x minus 3 over x minus 1. Okay, so the x-intercept would be the numerator's factor, so that would be just 3, 0. The 4 doesn't do anything. The y-intercept, if you plug in x is 0 to your function, you get 12. Okay, so 0, 12. Let's talk about asymptotes. The vertical asymptote is going to be at x equals 1, the denominator. The horizontal asymptote is the highest degree term. So if we take out our highlighter and look at the highest degree terms, oh, the ratio of the highest degree terms would be 4x over 1x, so that'd be y equals 4. So we got a horizontal asymptote at y equals 4. Got a vertical asymptote at x equals 1. Is there a slanted asymptote? No, because if you divided these two, it won't make a line. The degree of the numerator is not one higher than the denominator. Okay, so there's no slanted asymptote. There's no hole because there's no common factor. And if you get out your graphing calculator and do a second table, okay, and again, I would do the numerator in parentheses divided by the denominator. Don't use the fraction key. So your answers are in decimal forms. And you could actually plug this into your, your brain to say, okay, 3 gives you, negative 3 gives you 6. Oh, wait, we got 0 is 12. You got 3 is 0. 1, 2, 3 is 0. You've got 5 is 2. And so you're going to get this graph over here. There's no hole. If you, negative 1, I believe is 8. Negative 2, negative 3 is 6. So you can get a decent graph by looking at the table. And so you've got to be able to answer the question and say, what is going on? Do I know about the asymptotes? Can I find the x-intercept? Can I find the y-intercept? Can I graph this function? Okay, do I know what else is going on here? Okay, the bottom couple questions are going to be, let's see. If I factor the numerator, I'm going to get x plus 5 and x minus 3 over x minus 1. There's no hole. And if we look at our graph, we've got holes are on the side. The numerator is zeros or x-intercepts. The denominator is going to be vertical asymptotes. So let's think about this. Okay, so to wrap this up, I think the last couple of things would be define the x-intercepts. That would be at negative 5, 0, and then 3, 0. And then the y-intercepts would be, if you plug in 0, you're going to get 15. Okay, so then the vertical asymptotes would be no zeros, so, no holes because there's no common factor, so x equals 1 is the vertical asymptote. The horizontal asymptote would be 1x squared over no x squared, so that'd be none. No holes. There would be a slanted asymptote because the degree of the numerator is 1 higher than the degree of the denominator. So dividing it actually comes up with an additional asymptote. Okay, so if you divide x plus 1 minus 1 into that, you're going to get x squared. I don't know why this isn't writing. Minus 1x. So x squared minus 1x distributed negative 1. You get 3x minus 15. If you multiply this by 3, you're going to get 3x minus 3, distribute the negative. You will get a remainder, so the graph is not actually that line. It's not a specific line. So the slanted asymptote is y equals x plus 3. So starting at 3, you can go up 1 over 1, and that will be the slanted asymptote. The vertical asymptote is x equals 1. And so I think the big thing is if you take out your graphing calculator and write the quotient to those values, you're going to get additional points. So you have 0, 15. You have negative 5, 0. So that kind of shows you this graph is going to be over here. And then you also have, let's see, 5, let's see what this is, 3, 0. 1, 2, 3, 0. If you plug in, say, 4, you're going to get 3. So you're going to get some more points on this side of it. So it'll be these two branches. You'll have a vertical asymptote. You'll have a slanted asymptote. So I bet you're getting a a flavor as to what we're looking for. If you factor this next one, you're going to get x plus 2. And then on the bottom, x minus 2, you're going to get x minus 1, and then x minus 1 as well. The common factor is going to be x minus 1. So that's going to be the whole. Okay, there's going to be a whole at 1. And if you write the reduced function is going to be x plus 2 over x minus 2. So if you plug an x into the top and the bottom, you get 3 over 1, which is just 3. So there's a whole at 2. Pardon me, that should be negative 3. Okay, so 1 negative 3 should be a whole. There is going to be, let's see, the zeros will be at the other factor that's not used, so it'd be negative 2, 0. The whole does not actually function for more than one thing. So there's a whole at the value of 1. Okay, so that's going to be the whole. This numerator will be a 0. So negative 2, 0 is going to be the x-intercept. So there's only one. The vertical asymptote is going to be the denominator. So that's going to be x equals 2. So you go to 2 and make a vertical asymptote. The horizontal asymptote is the ratio of the highest degree term. So that's going to be y equals 1. Y equals 1. That's a horizontal asymptote. And then if you make a table of values, we could plug in, let's see, 3 and get 5. And then we also could do 4 is 1.5. And so you're going to get these points over here. And then we have a 0 at negative 2, 0. So honestly, we've got a pretty good graph using that whole and the graph that you see to the left of that vertical asymptote. There is no slanted asymptote because the degree of the numerator is equal to the degree of the denominator. On this one, quite honestly, there's not a whole lot of interesting things, okay? There is a horizontal asymptote at y equals 0 because 0x squared over that is going to be 0. You're going to get, let's see, if you plug in x is 0, you're going to get the y-intercept to be 5/12. Okay, so that's just up a skosh. And if you look at the graph here, yes, it has a vertical or horizontal asymptote, and that's it. It's going to just basically right above that x-axis. So no vertical, the vertical asymptote, there is none, because if you set that equal to 0, the horizontal asymptote is going to be y equals 0. No x-intercepts, the y-intercept is going to be as shown. No slanty asymptote because the degree of the numerator is not higher than 1 of the denominator. Thank you. Have a good day.